Hey everybody, this is James doing a unplanned new business preview. This is the Tetra Corporation's human resource machine. So the reason I didn't plan on doing one of these is, I don't have a tremendous degree of affection for the work of the Tetra Corporation, or their previous names that they went under. I'm blanking on right now. World of Goo is a fun game, I enjoy it, but it wasn't, there's people who have an extreme degree of reverence for this game, and I never actually played Little Inferno. I know people who like it. I know one person who in particular sings the song a lot, startlingly a lot, and seems to take a tremendous, worrying, way too much glee in that game's core ethos of burn shit. But this is Human Resource Machine, and this actually strikes a little bit closer to my area of expertise. Tap. So basically, Human Resource Machine has you... I'll show it, but it's all wrapped in this sort of like company that doesn't care about you but uses manager speak anyway kind of ethos. So, as you can see, this is my employee. I am simply called Employee 1. That's not because I got lazy. There's no name input, and I'm selecting my badge. So, I've been playing this game a bit. I'm actually somewhat far into it. You can see that's all the levels, but I'm actually going to start fairly early to kind of show off what the game is. Welcome, employees. So we'll start with the first level. This is sort of, these are years of your career and what part of the company you're working in. So I'm going to go back to being an entry-level employee in the mailroom. So here's the basics of the game. You're this guy right here. Let me tap him. Hello again. So, your job is to use these instructions you've got over here. Actually, let me go ahead and clear these out. To use these instructions you've got over here to build, essentially, a plan for doing whatever the instructions you have are in this little mailroom slot. So, this one's really easy. You just need to get all the things in the inbox in the outbox. Yep. Full of surprises. I've been here for 24 years. One day you can be just like me, but for now, back to work! Alright, but this one's really easy. I just want you to take all the things from the in to the out, so just in, out, go. I'm gonna go ahead and speed it up. Not much to it, obviously. It's a really basic program. And then you get these little challenges, which are... The size challenge is how many instructions you use. The speed challenge is how many moves it takes. And the difference comes from the busy mailroom, where you get the ability to do what are essentially loops, jumps, as they call them here. So basically, anytime you hit a jump command, you'll go to wherever the arrow is pointing, whatever instruction. So in this case, the directive is the same as before. Get everything in the inbox to the outbox, without just going in, out, in, out, in, out, in, out. But it wanted me to do it using this jump. So really, I just go in, out, and then I jump back to the start. So I'll just loop back around. So actually, I want to see what the optimization challenge is. It took me 30 steps. Huh. How does it do it in less than... So, obviously I can just do in, out, in, out, in, out, in, out, in, out, in, out, over and over again. And that's easy. But I'm trying to figure out how I can cut 5 steps out. Oh, I know how to do it. Oh. I've never used a copy paste before. I was hoping that it would just copy and paste. 1, 2, 3, 4. One more. I guess I could have looked at the line numbers. Whoops. I need 8. That's how you get less. Oh. Huh. I don't know. We'll come back to it. Or I will. You guys won't. So I'm actually going to jump ahead a little bit. So I've cleared all of these, but you can see the challenges have gotten much harder. Let's go to the Tetra Compiler, which I thought was kind of a neat one. So I'm gonna go ahead and clear. So to kind of give a little bit of background here, I'm a trained computer scientist. I have a degree in it. It's what I do for a living. So really all you're doing here is programming with a very fixed set number of commands. And you can see I've got a few more commands, and as the game goes, you get more of them. In programming terms, you and everything around you in this game it comprises what we call a finite state automaton, which is literally a structure that has a finite number of states, where the states represent the data that you can store. And in this case, you can see I actually have these spaces on the floor, and those are my data. So 0, 1, 2, 3, and 4. And then whatever your character is holding as he moves around. So as you move from place to place, or as this data gets updated, it's the transitions. So with the finite state automata, you have it in some fixed number of states, you will ultimately go from A to B, where A is your inputs and B is your destination. So in this case, they want us to multiply by... They want us to... excuse me. Take everything in the inbox, multiply it by 40, and then put it in the outbox. I can't imagine I sat here and did that. Tell me more. Wow. Wow. Wow, okay, that's dark. I'm not a fan of that. So... multiply by 40. I want to see what I did, because I can't remember how I did this one. Oh no! Oh no! It's gone! Oh no! Oh, that's not good! How did I do this? Did I do this? I mean, I know how to do it. Let's not do that one. Let's go look at my Octoplier suite. Octoplier, excuse me. So in this case, it was multiply everything by 8. So all I did was I just did add 2 a bunch of times. Oh, yeah, okay, yeah, that's right. I remember what I did. So the trick on this one, I'll actually go ahead and play it. Actually, I'll do it stepwise. So I'm taking 5 and I'm putting it into bit 0. So it's now in a state. And that state is I'm holding a 5 and the game has a 5. And then I'm adding what I'm holding and what the game has. So now I'm holding a 10 and the game is holding a 5. And I replace the 5. I just keep doing that. So now actually I've multiplied it by 2, because essentially multiplication is just adding. So like, if you multiply by 2, you're adding the number to itself once. 3, you're adding the number to itself 2 times, etc., etc., etc. So I started with times 1 already. So when I added the first time, it's times 2. Now I've got the number times 2, essentially. So now this is times 4 already. So if I save it and add them one more time, it's times 8. And then I can go ahead and put it in the outbox. And I hit play, and I'll just fast forward through these. And I am a champion. Really, programming is just understanding math. That's the fewest commands you can do it in, and that's the fastest you can do it. So Octoplier, or the I remember now how I handled the Tetra Compiler. The compiler. The trick on that one is that if you do 40, you can't just 40 doesn't square up, so you can just keep doubling. So you had to know at what point you needed to like save your work into a different variable, and then come back and get it. I think it's at 32 because it'd be 2, 4, 8, 16, 32, and then you had to go back and get the value for the 8 that you needed to save off somewhere else. So you know it's just kind of a pre-planning thing. All the ones on this side are actually considered to be harder, but occasionally you'll hit coffee break. Actually, this isn't a good one to show. That one's kind of. Let's do. Oh, there we go. Employee morale insertion.
And that, ladies, is how I saved a bundle on my long-distance telephone.
Just periodically these pop up.
Back to work, everyone.
A massive army of machines has surrounded the city.
Good.
The machines are not moving.
Yep.
And they are not communicating. Local authorities are investigating.
These pop up every so often, because again, each one of these is a year, and these pop up and they're just alarming and troubling. So everything that's lit up I've beaten. The Fibonacci one was kind of cool, but I'm actually going to go ahead and take a look at the mod module, even though I'm going kind of the hard path. So I might stop and cut somewhere along here because this is complicated. Yep. Thank you. Welcome to the corporate world. So in this case, it wants me to do modulus, which is when you divide stuff and you have the remainder. The modulus is essentially an operator to just get the remainder. So this is one of the situations where we have to understand that, like, multiplication is just addition, you know, chained addition. Division is essentially just chained subtraction. So when you divide 5 by 25, what you're really doing is you're subtracting 25. You're subtracting 5 from 25 until you hit 0. But if you were to subtract 5 from divide 5 by 24, you couldn't do it at some point. You'd end up with 1 left over. You wouldn't get to 0. And that 1 is your remainder. And in a modulus operator, you don't care about the 4 5s you were able to extract from 25. You really only care about the remainder. In programming, this is super useful for lots of, there's operations where this is actually a very useful piece of information to be able to get. I usually use it when I'm coding financial stuff. It's just like we have to deal with fractional sense in certain ways. It's very exciting, I understand. But in this case, they want me to take 2 items in the inbox. So 7 and 3 are the first example. And they want me to divide the first by the second. So in this case, they want me to divide 7 by 3. But they don't care about the 2 that I'm going to get out of that. They want that 1 remainder, the modulus. So in this case, I need to set up a state where I've got 7 and 3 preserved. Because I'm always going to need 3. But at some point, I need to be able to evaluate, is the remainder negative? And that's actually fairly easy to do because you can see I've gained a bunch of fun new tools to play with here. So the very first thing I'm going to do is I'm going to set up my state. I'm going to go ahead and I'm going to take I'm going to call this the divide. Terminator is what you divide by. I want to say it's this. I'll need that for later. So they gave me the ability to name these variables, which is super nice to have. So I'm going to go ahead and take the inbox and copy it to the divider. I'm going to go back to the inbox, and I'm going to copy to the terminator. So now I've got essentially the outline, and I'll need to jump at the end to take me back to the start. I'm going to put more stuff in there later, but we can go ahead and just do the first couple steps. So So I get it, I put the 7 in, throw the 7 away, which I love that little animation, him just chucking it. Alright. So the very first thing I need to do is determine if the terminator is bigger than the divider. Because if it is, then we don't need the then we already have our remainder. So if you were going to try to divide, say, 7 by 9, your modulus operator would give you 7 because you can't. There's no 9s in 7 essentially. So let's take a step back because if we're trying to be efficient, once we have the 3, we can already do the first test. Let's go ahead and stop before we even do any kind of copying. So this is subtraction, by the way. So let me get a reminder. You subtract the contents of the floor from whatever you are currently holding. The result goes back into your hands. Okay. So actually we are going to keep the copy 2 in there because it overwrites what you're holding and I don't... So I know what to do. I'm trying to be efficient, but let's just get started. Let's just go ahead and get started. So we're going to go ahead. I've got in my hands. I'm holding a terminator. So I'm going to go ahead and subtract the divider. You know what? No, I'm not going to do that just yet. I'm going to go ahead and copy from the divider. And because I only have one item I can carry at one time, I have to drop the stuff just to pick it up again. So now I'm holding the divider again, and I'm going to go ahead and I'm going to subtract. Let me confirm one more time. Yeah. So what you're holding is the base number. So I'm going to go ahead and subtract the terminator from the divider. So now if I'm holding a negative number, I can't divide this thing already. So if negative, go ahead and hit down here. Copy from the divider and send it. Oh no, send it to the outbox. Whoa, no, oh no, oh, little jumpy. Okay, if it's 0, just go straight to the outbox. Because if I'm holding 0, the remainder is 0. The two numbers were the same essentially. Else, so will that work? So let's think about it. So I'm gonna copy. Well, let's just do it. Let's just see what we get. All right, so I'm putting 5 in the divider, 3 in the terminator, 2, negative. Oh, nope, that won't work. That won't work. Copy to X because I don't want to use X just yet. Because if I get a negative, I want to keep the value of X. Right? I think that's right. Let's try it again. Because if I were to pull from the divider, what you saw was I was basically restarting. I would have got caught in what's called an infinite loop. I would have never hit a state where the number ended up less. Nope. Right back to 5. So I'm having to manage 3 variables effectively. But we can still do this. We get 1, drop it in there. Oh, it's negative. Go back and get it. Put it in the outbox. And we go back to the beginning. We'll just speed this up. Really? Okay. All right, so the divider is 2. Oh. Okay. Okay. Easy enough. Easy enough. So in this case, it was ultimately this is when scoping your variables, which is another programming concept, is super important. Variables persist data, and depending on the programming language, how long they keep their data and where they keep their data is, where in the code that data is still accessible, is different. But in this case, everything is universally scoped, which means that data persists forever until the program, i.e. the automata, i.e. me, stops working. So because I wasn't overriding X in this one case where I just needed to get that value from X right away, it just had the value from the previous run in there and was able to, and just grabbed it. It was actually garbage data, so I put garbage data, that 1, into the thing. So let's try it again. Speed up a little bit. Which is why that they did that case. They knew that at some point somebody was gonna catch you. There we go. Problem solved. In fact, I watched him, like 5 of those happened later, so not even close. Yeah, so there's some efficiency I can bleed out of this one, but I'm not sure where it is. But I actually really enjoy this game. It's, even though a lot of it's kind of easy. I mean, I've been programming for a long time. There's something about it. Like, it's a really good kind of just programming problems refresher. So we'll do one more, but then we'll probably just call it. Asshole. Now we have division. Wait, do we? No, we don't. So yeah, earlier he told me you don't have to divide. Well, I don't have a divide operator. So I'm assuming there's a mathematical formula for getting modulus that I can't remember. I wouldn't be surprised if there is one. So, but again, for each of the 2 things in the inbox, how many times does the second fully fit in the first? Don't worry. Oh, I see what he's saying. So he was saying before that I didn't have to worry about it because he only wanted the modules. He didn't actually want the division. Now they want the division information. So in fact, I'm going to take him up on his offer. I'm going to go back and grab my modulus operator because ultimately I just need to persist one more state and at the end grab it. So I'm going to go ahead and copy all this. I'm going to paste it back in. This is actually kind of a cool one because you get to see programmatic reuse, which is another fun part of programming. So all of the operations I'm doing are largely the same. It's debatable if I still need X. In fact, I'm going to say I probably don't need X. Do I use X for anything interesting? Yeah. Yeah, let's keep X. Let's keep X. So I'm just going to declare a new variable. It doesn't hurt to have X, and I'm pretty sure I need it. So the very first thing we're going to do is we're actually going to copy this 0. Oh, wait, no. We're going to grab this 0, and we're going to copy it to this guy. The reason I'm doing that versus just overriding 9 is I have no way to reliably get 0, and I don't want to lose 0. So, there are actually some machine languages where crap like that is actually a problem, and it's why I hate college. Having to remember garbage like this. Alright, so now we need to actually track the number of subs. So if it's negative, we go to the end. If it's 0, actually, I want to go ahead, I'm going to bump, which is essentially just saying add 1. And hold on, actually, before I do that, does bump put it in your buffer? Let's check. Yes, it does. So, I need to be aware that I'm going to lose the value I'm holding when I do bump. And go grab X. Okay. If it's 0... So if it's 0, I'm going to go ahead and I'm going to bump X again. Wait. Yes. I don't need to copy from because I'll already have it. All right. I think that's it. I think that's all I had to change. So I'm just using X as essentially a counting mechanism. I just keep counting on 1. Bump plus takes the value in that field and just increases it by 1. And also, I don't want to bump X. I want to bump the divider. Oh, that would have been bad. Wait. Undo, undo. No, what am I doing? God. Alright. I'm gonna just watch. Okay. Easy enough. 8, 8, 4. Yep, it works. Bump that guy. That's why I have to do it, because he picks up the 1. 0. Whoops. So, we have a programming error. Not a logic error. This is just me screwing up. Jump if negative. If 0. Oh. Yeah. Yep, that was me. Wait, what? Copy pasting code. This is the best part. Alright, so I have 6. I go and I bump you. Oh, I do need a copy from. Because. Oh, crap! I hope I saved my progress. Please. Okay, good. We're good. I need a copy from. Copy from X. Negative. Oh, no, I don't want that. That's wrong. That's very wrong. So I don't want to bump because I know... Wait, if negative... Oh, these are backwards. There we go. Because if it's 0, it was a full. If it was negative, it's not. So then copy from count. Because I can't be sure on the negative case that I have it. It may not be necessary, but it's... How this program is structured is good to have it. Three. Yes, good. All right, so we reset our count. Then we reset the other two variables, the divider and X. And that's the terminator. So I get 2. That's negative, so I just go grab the count, take it to the box. There we go. Wow. I can tune that one a lot. So that's Human Resource Machine. You can see there's a lot more to go. You know, it starts really simple. It's already getting a little complicated. This is kind of stuff that I might do in like a second year, early second year, late first year programming class. You know, diagram a finite state automata to do division. It's cool. Like I actually think that if you have interest in this kind of programming, this is a neat little toy to kind of learn how some of this stuff works. It's not too rough. It's not super complicated, and even if you're not interested in that, it's a neat puzzle game. It forces you to kind of think very procedurally of how do you solve something that we may take for granted, like addition. Like how do you put addition into executable steps that someone who's never heard of the concept of addition, or excuse me, multiplication, someone who only knows addition, like say a really basic processor which really can only add things, how do you put that in terms that thing can understand? And I think doing the base challenge is fun, but I think the idea of trying to solve, to create the most efficient machine possible is where I'm probably going to end up dumping a tremendous amount of time. So I talk about this more on episode 451 that doesn't have a name yet. I'll be naming it today probably. And that comes out it came out on Sunday, November 1st. So feel free to go listen to Ready Free Nintendo and hear us talk more about this game and other stuff. Blanking on what we talk about this week. I'm a terrible host. Thanks for watching.